This is the arrangement for our project on instrumentation and measurement. We have a photodiode receiver here and a sender. So, and this system, the arrangement is powered by a DC voltage, a DC source, and this fan from the DC motor is painted white on the one side, so that it reflects. It is a reflective surface. So the speed measurement is achieved by counting of the rising interrupts in seconds. That provides the RPM measurement, which is received by the IR receiver. The interrupt is then counted by the Arduino and is provided to the display in the LCD. So we perform a demo of this speed measurement. So as you can see, when the IR receiver senses that there's rising interrupts, the LCD displays the RPM here.
This is the coding for optical tachometer and temperature sensor. With this code uploaded into the Arduino board, we will be able to measure and record the speed and temperature signals that the measurement sensor will measure, and we'll be able to display it in the LCD as well as view it via computer. Now, to go through the code, the first we have to do is include the liquid crystal library, so that we will be able to use the liquid crystal display in our project. And after that, we have to declare what all the pins that are going to be connected in the Arduino board. Then these are the variables that we have used to convert the signals gathered from the sensor to a value which will be displayed in the LCD as well as in the computer. So with this code, what we have done is we have initiated a variable RPM count, which will count each rising interrupt generated by the rotating blades of the rotor in test, so that each interrupt will be counted, and then it will be calculated how many interrupts are there per second, and then the appropriate RPMs will be displayed in the LCD as well as in the computer. Now with this code, what we are going to do is this will initiate the serial port that is there in the Arduino board, and from this serial port, data will be sent to the computer. So what this will do in later on when we implement it is, we will be able to send the signals to the control system, so that way motor speed can be controlled, getting the speed signal from our measurement system. So the actual loop what we have established over here is for the program to run continuously, so that the values, the speed and the temperature measurement will be there continuously. And to display these values, we have kept a delay of 1000 milliseconds, so that the change in the measurement readings will be displayed only after a delay of 1000 milliseconds, so that we do not get a variable reading but a fixed reading, so that we will be able to see and record it accurately. And these are the codes that we have made, and with this serial print, it will send the data to the computer, and these are the codes for printing it in the LCD.
These extreme two terminals are powered up using the 5V DC, which is extended from the Arduino Uno board, and middle leg it sends the output, and it feeds the signal to the Arduino Uno board of the analog signal. And the working principle is this temperature senses the signal and it feeds the signal to Arduino board, and as per the program code uploaded on the Arduino Uno board, it again converts the analog signal to digital signal, and it feeds to the display. And the temperature out here is 22.95 degrees Celsius, and it can vary as per the rise of the temperature. See, it's changing now. It's in the rising pattern. So this way it